Okay, so we're looking at linear equations, or equations that when we're going to solve them become linear equations, and solving those. And so when we're looking at linear equations, a couple of things can happen when we're solving equations. We can get a solution. We could get something that there's no solution, or we can get where there's an infinite number of solutions. And so let me just change this view. So for example, oh great. Come on. Okay, for example, let's say we had 3 all times parentheses x minus 2 is equal to 5 all times 2x plus 6. Okay, so when we're working to solve equations, the first step you want to do is you want to simplify each side of the equation as far as possible. And so you are going to distribute if needed, combine like terms if needed. And so here we notice that there's a 3, there's no sign in between the 3 and the parentheses, so that's multiplication. And so we can distribute the 3. And doing that, we get 3 times x, which is 3x, minus 3 times 2, which is 6, is equal to, so same thing on the right-hand side of the equation, we're going to distribute the 5, and so we get 10x plus 30. Okay, so looking at this, once you distribute, combine like terms on each side of the equation, so 3x minus 6, we say these are not like terms because they both don't have the variable. Same thing on the right-hand side of the equal sign, 10x plus 30, those are not like terms. Notice that it's a linear equation. Linear equations, the variable, the highest power is 1. And so linear equations, we solve these different than other types. So you're going to get the variables to one side, constants to the other side. And so whatever you do to one side to make it equal, you have to do it to the other side of the equation. So if you subtract 10x on both sides and add 6 on both sides, combining like terms, 3x minus 10x is negative 7x equals 30 plus 6, which is 36. We got variable, term with a variable by itself, constant on the other side. We need to get rid of the negative 7 in front of the x. So we can either think of it as dividing through by negative 7 or multiplying by that reciprocal of the coefficient in front, which is negative 1/7. Then whatever you do to one side of the equation, you got to do to the other. And so we get x is equal to negative 36/7. So always reduce your fraction if possible. So at this point, if I was doing this on MyMathLab and entering this in, I would read the directions and see how they wanted it. If they asked for a fraction, I would leave it like this. If they asked for a mixed number, then I would have to divide into. So 7 goes into 36 5 times with a remainder of 1, because 5 times 7 is 35. So we get negative 5 and 1/7. Or it could ask for a decimal, and we could do that too. If it doesn't ask for a particular form, then you could write whatever form that you want. Okay, so let's say you had 3 over x minus 1 is equal to let's say just 5. So starting with this, I have actually a variable in my denominator. And so if you have a variable in your denominator, it's sometimes useful to see what variable that variable cannot be. So for instance, if you look at this, if I got my value of x equals 0, and I plug in 0 here, this makes this undefined. You can't have 0 in the denominator, divide by 0. And so we know here that x cannot be 0. So if I go through here and I solve for this and I find that my solution says x equals 0, then I know that that is not correct and I would have to exclude that from the solution set, and it's possible it wouldn't have a solution. So let's maybe isolate this 3 over x first. I notice if I add 1 to both sides, we can combine the 5 plus 1. So we have 3 over x is equal to 6. So if you ever have anything in the denominator, we can, and it's an equation, not an expression. Right now we're working with equations. We can clear those fractions by multiplying both sides of the equation by the LCD of all the fractions within. And so this we can think of as 6 over 1 if you wanted to. And we're going to multiply both sides by the LCD, which is x. So the whole point of that is so that your variable will cancel with the variable in the denominator, or whatever's in the denominator, so that it will go away. And so our x's cancel here, and we're just left with a 3 is equal to 6 times x. So we want to get x by itself. We can divide both sides by 6. And so we get x is equal to 3/6. And so this can be reduced. And so both have 3 in common. 3 goes into itself once and 3 goes into 6 twice. So this kind of helps me to remember to check if this is okay, because it's not the same value as I said x couldn't be. So x is 1/2. Okay, so any questions so far?
Nope.
What if we had 1 all over x squared minus 4 is equal to 2 all over. I wish I had my textbook here. I love just pulling them out of my textbook, and I don't have it here. Let's say 1 all over x squared. Okay, so looking at this, it's an equation. I want to solve this. If I notice I have variables in the denominator, so we need to find out what x cannot be. And so we could start out, if we wanted to, by factoring this. And so notice you have 2 terms, so factor 2 terms, look to see if it's a difference of squares, which it is. And so I can factor this as x minus 2, x plus 2. And so now we have 1 all over x minus 2, x plus 2 equals 1 over x squared. So I can tell here x can't be values which would set the denominator equal to 0. So in this case, x cannot be x minus 2, the value that would set that equal to 0 is when x is 2. So x can't be 2. X plus 2 is 0 and x is negative 2. So x can't be negative 2. And x squared equals 0 and x is 0. So let's clear our fractions by multiplying by the LCD. So our LCD is actually this x plus 2, x minus 2 all times x squared. It actually might be easier if we just kept it in the form where we didn't factor it there. If we did that, we could multiply both sides of our equation multiply the LCD, which would be x squared, all times x squared minus 4. Okay, so I have this x squared times x squared is 4, all times this 1 over x squared minus 4 is equal to 1 over x squared, all times that. Again, the whole point of doing that was so that things would cancel. And so x squared minus 4 cancels with this x squared minus 4, and then you're left with just x squared on the left-hand side is equal to x squares cancel over here, and we're left with x squared minus 4. Okay, so looking at this, I notice it's not linear, and we tend to solve linear equations differently than we do with quadratic. Quadratic, a lot of times you just set that equal to 0. But notice if we get everything to one side of the equation and we subtract x squared on this side, we're getting at 0 is equal to -4. Which my variable disappeared, and I know 0 doesn't equal -4. And so since this is false, this tells me then that the equation we started with has no solution. So if your variable falls away and you have a true false statement left, then there's no solution. If our variable had fallen away here and we had ended up with something like -4 equals -4, then if that's a true statement, and then we would say any solution would work, or any variable would work except for the ones that had set our denominator equal to 0. So a lot of times when I'm going through these, if you understand it and you remember how to do it, a lot of times, and it might be faster, you can just start working through it and then kind of check back and see that you're getting the right thing. Stop share for a sec. Shoot. Problem is, guys, okay, so just pulled a problem from MyMathLab, and we want to solve the following. And so here we have x all over x minus 8, and then plus 3 outside of that parentheses equals 8 all over x minus 8. So I don't need to factor the denominator. I notice though we have a variable in the denominator, so it's helpful to figure out what x can't be. And so looking at this, x cannot be 8. And so if we get a solution where we get x is 8, then this would actually have no solution. If you look at this, we're looking at the least common denominator, and our least common denominator is just this, x minus 8. So since it's an equation, we can, whatever we do to one side, we do to the other, and it remains equivalent. So I'm going to multiply x minus 8 on the left-hand side of my equation. But the thing is, you have to multiply every single grouping by that x minus 8. And then I'm also going to multiply x minus 8 on the right-hand side of that equation. And so technically, I have this x minus 8 all times this x all over x minus 8, plus I have the x minus 8 times the 3, is equal to this 8 all over x minus 8 times x minus 8. Okay, so since we did that so that our denominators would go away, and so x minus 8's cancel there, and we're just left with the x for this first grouping, plus, well, let's distribute that 3 into the parentheses x minus 8. So doing that, we get 3x minus 24 is equal to, again, the x minus 8's cancel, and we're left with 8. So once I've cleared my fractions, I notice this is a linear equation. And so let's combine like terms on the left-hand side of the equal sign. And I notice that like terms, we have x plus 3x. So x plus 3x is 4x minus 24 is equal to 8. So I want to get all the terms with a variable on one side, constant on the other. So if we add 24 to both sides, we get 4x is equal to 8 plus 24 is 32. Divide both sides by 4 to get x by itself. We get x is equal to, well, 8 times 4 is 32. So 32 divided by 4 is 8. Okay, so notice this is the value we said that x could not be. And so here there would be no solution. I'm going to see if I can. Oops, sorry. Let's come down and see. Okay, so let me fold this problem. Okay, so you have x all over x squared minus 4 minus x plus 2 all over x squared minus 2x is all equal to negative 3 all over x squared plus 2x. So we have x all over x squared minus 4. And so let's factor that x squared minus 4 as I'm writing this out. And again, that's two terms. So, and it's a difference of squares. So x squared minus 4 can be factored as x minus 2, x plus 2. And then we have a minus next fraction, which is x plus 2. And that's all over x squared minus 2x. You look at x squared minus 2x, both of those terms have an x in common, so we can factor an x out of both of those terms. And so pulling an x out of x squared plus 2x, or sorry, minus 2x, we get x all times x minus 2 is equal to negative 3 all over x squared plus 2x. Again, x squared plus 2x, both of those terms have an x in common, and so we can pull an x out, and we would be left with x times the quantity, x plus 2. Okay, so looking at this, it's an equation. I notice I have variables in the denominator. So determining what x cannot be 2 or negative 2. And x can also not be 0. So we want to multiply every single term on each part of the equation by LCD. And if you look at this, the LCD is x times x minus 2 times x plus 2. Okay, so we're going to multiply every single grouping by that. So we're going to multiply this x all over x minus 2, x plus 2 by that. So I'm just going to write it here, x times x minus 2, x plus 2. I'm going to write it here. So we're multiplying this piece by x times x minus 2, x plus 2. And we're multiplying this by x times x minus 2, x plus 2. So we did that so that things would simplify and cancel out. And so what they have in common in the numerator and denominator, we can cancel. The only reason we can do that is because this is strictly multiplication here. If there had been addition in between any of these parentheses, then that wouldn't work. But again, we chose what we could so that our denominators would go away. And so we're left here with x times x. And I'll do that in a minute. So going to the next grouping, reducing that fraction, we have an x in common in the numerator denominator. We also have an x minus 2 in common in the numerator denominator. The last part of the equal sign, we have an x in common. We have an x plus 2 in common. Okay, so simplifying each side of our equation down, that first grouping, all that's left in the numerator is x times x, which is x squared. Minus, so what we're left in the numerator over here is this quantity x plus 2. So you need to keep the parentheses, all times x plus 2 is equal to, and then over here we have this negative 3 times the quantity in parentheses x minus 2. So we need to be careful because we either need to distribute this negative in first and then distribute out these two binomials, or we need to keep this negative out front and first distribute. This negative, it has to be distributed to each one of these terms after we multiply it out. So it'd be wrong just to drop the parentheses here once we distribute. So we have an x times an x, which is an x squared. We have an x times a positive 2, which is a 2x, and plus another 2x. So 2x plus 2x, our middle term would be 4x. And we have 2 times 2, so this is plus 4. So if you FOIL that, or if you multiply that out, and you distribute and combine like terms, you get that, what is left in the bracket, x squared plus 4x plus 4. So distribute the negative 3 to the parentheses x minus 2, we get negative 3x plus 6. This negative here has to be distributed to each term inside that bracket. So change the signs. So we get x squared minus x squared minus 4x minus 4 is equal to negative 3x. Okay, so at first it looks like a quadratic, but the x squared minus the x squares cancel out because they're like terms. And then we have negative 4x minus 4 equals negative 3x. We want to get x by itself. So if we add 4x to both sides, we'd be left with negative 4 on the left equals negative 3x plus 4x is an x. So x is equal to negative 4.
Professor?
Yeah, what happened to that 6?
Yeah, I was going to ask.
Did I drop a 6? Yeah, so that changes it. I forgot to bring down that 6. Thank you. Plus 6. So that's actually going to change everything, right? So let me just bring it down here. Thank you. So I do that, and it's great to have students to catch her. So let me, again, add 4x to both sides. Let's just do it here. And if I'm adding 4x to both sides here, let's subtract 6 to get the constant on the left. So negative 4 minus 6 is negative 10, is equal to negative 3x plus 4x is 1x. So x is equal to then negative 10. That's not one of the numbers that we excluded from the original, and so we're okay as long as you did your math right, and x should equal negative 10. So some of the homework might ask, is x equals negative 10 a solution? And so how would you show that's a solution?
Plug it in.
Plug it in, plug it in. Great commercial. Sorry. Yeah, plug it in. And plugging it in, you just need to make sure that as you simplify it down, that you get the same value on each side. You get a true statement. If you plug it in and you got a false statement, like 0 equals negative 4, like you got for one of our problems, then it's not a solution. So you kind of get a feel of how I lecture. I'm thinking that I will start class probably on Thursday, maybe where you guys try a couple examples, make sure that you got it, and then we can move on. I didn't finish this 1.1 section. There's a little more in there where you're solving an equation where you have multiple variables for one variable. And so I will go back and I'll go over that on Thursday, as well as some probably a couple other sections. Let me just stop the video for now, if I can ever find it.